Welcome back, everybody. I'm on a roll today, so I want to just finish up the P's, and we're going to look at prop and the associated prop functions, and then we'll be done with the P functions. The prop we've looked at several times, and it's pretty simple to make by yourself. If I'm going to make it curried, and it doesn't like it when VS Code doesn't like it when I use name as a argument, so I'm just going to call it string or str. And then we would take an object and we would return this, the, however you would say that, the looking for the string that we pass in inside the object and return the value for that. So if we log that, we have to call it like this. So I'm going to look for a prop called name and then we have to call it like this because my function is curried, and we're going to use d.obj. I will log out what d.obj is. It's coming from, sorry, d.obj. It's coming from this library, some data, just so I don't have to keep creating data. I didn't save. All right. So this is our object. It has an ID, name, and active property in it. And we're trying to get the value of the name, which is test. And that's what we did. And then we could just, I think it's more common to say like prop name or something. And then we just pass in the object, but we could just destructure the object and get the name property out of it. And then so that's what we want. So we just return it. And then we could just do prop name and pass it our data and get the same thing back, test. But Ramda has this function built in for us. So we could just say prop, and the first argument would be name, but we have to put it in a string. And we could partially apply it or call it at once. I'm calling it all at once. And we get an error because I need to pass in the index, which I did, and that's name. And then I need to pass an object, which I did. Oh, is this a Ramda function? R.prop. Yeah, and we get test. Yeah, so that's how the this works, and it's very useful for partially applying it, like I just did, where say prop name is equal to r.prop. Oh my goodness. R.prop name as a string. So now we just need the data, prop name, because if you're going to be trying to get the value of the name property out of an object over and over again, might as well just go ahead and partially apply it so that when you're doing this, you're only having to pass one argument at a time and you can reuse it. So that's prop, and that's the basics of all these other functions that we're going to look at. And remember, prop is similar to pluck and pick in many ways. I mean, as far as you're trying to get something from an object or some things from an object. But let's be complete and look at the type signature. Um, it takes an index, and an index could be a string and enter a symbol because keys and objects are strings, but arrays are objects and the keys are numbers, so that's an integer. And then you can use a symbol, which is like not something we do very often. Um, it returns a function that when supplied an object, it returns the indicated property of that object if it exists. Um, and so here in the second example, we're trying to get the property X off of a empty object. It does not exist, so we get undefined. So this is an example of what's called a partial function, not a partially applied function, but a partial function, which means that there are some inputs that you give it which are not going to give you back a useful value. They're going to, and when I say useful value, I mean something other than undefined or null. And I might even throw not a number in there, but maybe not. Uh, if it was, if it did not ever return undefined, if it always returned a value, then it would be called a total function. And so Ramda, one thing that some people don't like is the fact that their functions are sometimes partial functions. And we try to strive for total functions. And that's where Sanctuary JS comes in, which is a branch of Ramda by one of the original Ramda contributors who had a bit of a different philosophy. He decided that he doesn't want 240 functions to choose from. He wants to simplify it, but he wants those simplified list of functions to always be total and never return something like undefined or null in certain cases based on the input you give it. So that's just something to know. We've looked at nth and project and pluck and props and path, so we don't need to dig into those anymore. But let's dig into this prop equal. The prop is an object function. This is a relation function, but related. This one's going to take an A and a string and an object and return true or false. So this is a predicate function. So A is the value, and this is the value to compare the property with, right? Because it's a Boolean, so we need to like ask if something's equal or greater than or less than or something. Maybe includes a lot of things you could do. The string is the name of the object's property key. So very simple to the index in the prop example. And then the object is our data. This is the object to check the property in, and it's going to return Boolean. True if the value equals the specified object property, false otherwise. So let's take the description first and then see if it makes sense. And if not, we'll do the examples and then go back to it. The prop equals returns true if the specified object property is equal in terms of r dot equals, which remember has some special functionality compared to the equals or compared to the triple equals in JavaScript. Returns true if the specified object property is equal to the given value, false otherwise. And you can test multiple properties with r dot where equals, and test nested path properties with r dot path equals. So I think we've looked at path equals already. We might look at r dot where equals. Why not? Um, so let's just grab all of this and then make sense of it. All right, so here we've got four objects and they have name, age, hair properties on them all, except for this last one, does not have a hair property, but it does have a disposition property. And then we just group all these objects into an array called kids and partially applied prop equals. So the first one is brown, and that is a that is a value. All right. And these two, Fred and Rusty, both have hair that is brown. And then hair is the key. So we're passing in a value and a key. So here's the A and the string. The next, all we need is the data. So we're partially applying this, we're just not passing the data yet. And so it's going to look in there and it's going to find out if the hair for each object is the hair property brown, right? So again, we're doing this reversal where we do like the value first and then the prop. Um, and if it's true, then we're going to get back the name of the name of the items in here where that is true. And in this case, we're going to use filter, but first, let's just pass the names like this. Oh, not kids, names, but kids. Let's pass the kids like that because it says we're supposed to get Boolean, true or false. And we're not logging it. Let's just log that. And we get false. But that is not correct because we need to check all of these guys, and prop equal does not loop through the thing. So we need to loop through it. So that's why we're using our net filter. And this is has brown hair is pretty true. So I think we need to, for some odd reason. Oh no, no, no. That's right. It's just because I did that. And again, we need to log it. Oh, yeah. And here we go. So what it gave us back is a new array with the objects that pass this has brown hair. And both of these, Fred and Rusty, have brown hair. And that's why we got that back. So this would work, I think, if we just passed one kid in there. So let's do that. Let's just pass Abby. And Abby has blonde hair, so we should get false. But if we passed Fred, we get true. And then if I go back to the filter, if we place this with map, we should just get an array of booleans. Yeah. And so Abby's false, Fred and Rusty are true, and that Aloysius or something. I don't know how you pronounce that. Anyway, false because they don't even have a hair property to begin with. So that's why it's saying it's true if it passes, otherwise it's false. And so like undefined is like, no, it's not true, so it's false. So you can't really check. I'm trying to wonder, does that mean that like if you checked if it was specifically false and it wasn't, then it would be true? I don't think that's the case, but that doesn't really matter here. So that's prop equals. Let's read the description one more time now that we've played with it. So it returns true if the specified object properties equal in R equals terms to the given value and false otherwise. And then it says you can test multiple properties with r dot where equals. Right now, we're only testing one property, the hair, and you can test nested path properties with r dot path equals, which we looked at, where you can provide like how to reach the object you're looking at by passing in the prop keys, like first you'd say name, and then if this was first and last, then you would say first, and then it would give you then it would reach the value. You can go back and look at path equals um, if you want more of a explanation. We're going to move on. We're going to move on to prop is, and this is a type function. So this one takes a type, a string, an object, and gives you a Boolean, true or false back. All right, so nothing new there. So it returns true if the specified object property is of the given type and false otherwise. So you're checking types, and can be very useful so you don't have to write an if statement to check if something's a certain type, because you may want to do one function body implementation if the argument is a string, and another one that if it's a number, or you might just want to early return if it's not a certain type, but this lets you do it concisely. And they've got good examples here. So I'm going to grab these and get rid of the comments. And then we'll just do a log and drag each one in at a time. For this one, we're passing in the first argument, which is a type. So we're passing a number, select the number type, and then a string, X. And then we're going to pass in the data. And so it's going to look for the prop X, look at the value, and see if this value is a number. And if it's not, if it is, we'll get true. If not, we'll get false. And it is a number, so we get true. And here, X is not a number, so we should get false. And then here, X is not even in an object. The object's empty. So we get false too. Because again, if it's true, it's true. And if it's not, it's false. But we're checking to see if it's true or not if it's false or not. And then it says C also is, which we've looked at, and propSatisfies, which we'll get to in just a second. And then we move on to prop or. Let's keep the. Now this one's cool. This one is basically like prop, but prop can give you back a value or undefined. Prop is returns true if the specified object property is a. Oh, sorry. Returns the specified property of the given non-null object if the property is present and its value is not null, undefined, or nan. Otherwise, the first argument is returned. So that's the key to this, is that there's a default value. If instead of getting undefined, null, or not a number, you get the default value back. But if it isn't null, undefined, or nan, you get back the value of the prop that you're looking at. So this is as good as anything. Let me yoink that. And we've got Alice. Name Alice, uppercase, age 101. Alice is pretty old. And then we've got a partially applied function called favorite, where we access the prop favorite library, which does not exist. So we would get undefined. But we also have our favorite with default, which is prop or. This is just prop. The Ramda is our default value, and favorite library is our um, prop that we're going to try to check. So we're just going to compare the difference of using prop versus prop or. And I know we can see the output here. I'm deleting it, but we'll just log it, log both together. Save it, clear the console, and run it. And so for this first one, favorite Alice, we get undefined because we're using prop. But when we use prop or, if the value is undefined, we get back Ramda, our default. But if we passed, instead of looking for favorite library, if we looked for name in both of these, we should get Alice back for both. And we do. So it's gonna work just like prop if the value is in there, but if it's not, it's gonna return a fallback. Very clean and concise. I like it. And let's move on again. Let's go take a look at props with an S. And if we go back and look at the prop type signature, we take an index, an object, and we get a result or undefined back. With props, we take a list of keys and an object and get a list of values back. So this acts as a multiple prop, arrays of keys in, arrays of values out, and it preserves the order. Again, we'll take this and let's just log these one by one. Looks like there's multiple examples, and we'll run it and make sense of it. All right. So here, instead of just asking for the X prop, we're asking for the X prop and the Y prop from these objects. And when we call prop or props, we get the values back. And that's why I get one and two. If we asked for X and Z, that does not exist in our data, we get one and undefined. Uh, and remember, we just looked at prop or going to see how do you pass multiple values and fallbacks. Maybe you can't. Maybe you just have to map through it because that would get kind of messy with having a different fallback for each undefined prop. So anyway, that's a side note. Uh, and then if we looked at this one, we're calling props. We're passing in C, A, and B with a value with an object to look through with a B and an A. There's no C, but also the order here. It says that it preserves the order. So we want um, an array back with values in the order C and then A and then B, even though that's not the same order here. So when we run that, we get undefined for C, one for A, it's second, even though uh, it's the last thing here, but it's not the last thing here. So this is the order that it's preserving. And then still gives you the undefined. So, but if you did this, you could just filter using Boolean, the Boolean constructor as your predicate function for filter. And this list is as your data, and then it would give you back a new list, which is one and two, because undefined would be coerced to falsy value, and it would not pass. So this isn't the end of the world if you get that. Yeah, so that's our props. And then there's another example here. We might as well look at that. All right, so Tony Bullet Tooth is the result we're looking for, and that's what we'll log. And here we're using compose, so we're doing right to left composition. Just going to clean that up a little. Let's run it, and we get Tony Bullet Tooth. So we knew that already, but why? Because we're taking our full name and we're composing. We're going to make that a function, which is the composition of first grabbing the value of the props first and last. Then we should get an array of values. And then we're going to join those values together with an empty space. And that is our result. And then since we partially applied this, we're passing our data into full name with a last and an age and a first, but we just want the first and the last. And then we format it with the join, and that's what we get. So that is our props. Also very useful. I think prop and props might be on that like B tier of usefulness in Ramda, in my opinion, where A tier functions would be like pipe and compose and filter, map and reduce. Um, but I think you'd be reaching for prop and props very frequently. And I don't even know if I'd ever use prop anymore now that I know about prop or, because that just saves you some headache. Because at some point you're going to have it undefined. So I like these a lot. And then we'll finish up this video with propSatisfies. And so I can already tell by the name that that's going to be a predicate function. But the first function is a predicate. It takes an A and returns true or false. And it's going to take a string, and it's going to take an object where the key is a string and the value is of type A. And ultimately, you'll get back true or false. The logic function. Um, and I can tell already that this A is going to be the A in the predicate function. And this string is going to be the key from this object. Let's look in here. The predicate, the name, the object returns Boolean. It returns true if the specified object property specifies the given predicate, false otherwise. You can test multiple properties with r.where. Um, I'm going to wait till we get to the W's before we do this. Let's just finish up. Oh, let's finish up by looking at this example. We'll log the example. Is there a keyboard shortcut that I can do that when I paste doesn't make prettier format it? If so, please let me know. I'd be very thankful. I think it's easier to look at it like this. So here's our predicate function. It's going to take an x and return whether x is greater than 0. Um, this is confusing because this is x, but this x has to do with the property name. Let me just rename this to Z, just so that they're different. Yeah. So first, we're going to actually grab the value of X from the object if it exists. Then we're going to check if that value 1 will be Z, and if 1 is greater than 0, which it is, it's true, then the prop is satisfied and we'll get that back. Otherwise, we would get false. So it's true. But if this is a -1, we would get back false. And if this was a X's with a +1, we're also going to get false because it's false if it's not true. True if it is, and false if it's not true. That's prop satisfied. Um, let's just take a quick peek at where. We won't do any examples. This takes a spec object. Oh, that's super cool. Okay, I know what this does already just by looking at it, and it reminds me of the apply spec function, which is also super cool. I kind of forget about it. But this just gives us something to look forward to. Um, so I'm going to end it here with propSatisfies, and we finished the P functions, and now we're going to jump into the R's. We're getting we're making some serious headway. Like in this rebuild function, we've already looked at map keys and rename keys. Yeah, so we're getting a lot of bang for our buck by having taken detours. Anyway, I'm just rambling. Thank you for spending your time with me. Tell a friend, and I'll see you in the next video.